On this question, we're asked to solve the polynomial inequality and graph the solution set on a number line, and then express the solution set in interval notation. To solve this kind of situation, I'm going to follow a four-step process. First, I'm going to solve this thing set equal to 0. And then I'm going to write the solutions, and we're going to call those boundary points. And those are going to be wrote on a number line. Once we've set up our number line, we'll have set up intervals. So we're going to write those intervals and choose some test values from within inside the interval. And then we're going to write a table and check all the intervals that we have solved from using our boundary points. So let me show you all how this one starts. The first step is to take this equation or this inequality we have up above and treat it as an equation set equal to 0. Okay, so that's step 1. So once we get it in this form, it's already been factored into two factors, so I can take each factor and set each of them equal to 0, and then we can solve for x. Adding 7, we'll have x equal to 7. Subtracting 4, we'll have x equal to negative 4. And again, what I'm calling these solutions are boundary points, which we use in the second step. We'll write these two numbers on a number line. Here, negative 4, and here I'll put 7. Just to kind of put them on a number line so that we can see where everything's located. So now, once we get it set up this way, we're going to write our intervals from our number line. So watch what we have in the original inequality is a greater than 0 situation. That means we're going to need to use parentheses in our interval notation. So when I write it down here, I'm going to put parentheses on either side of 4 and on either side of 7. Meaning I have the intervals negative infinity, comma 4, parenthesis, another interval, parenthesis, negative 4 to 7, and then another interval, 7 to infinity. So we have three intervals. And again, using parentheses because we have a greater than. If this had been greater than or equal to, then we would have used brackets instead. But that's the only difference. If you have a greater than or less than, then you're going to need to use parentheses. Alright, now we need to choose some test values. So this would be step 3, is some check values, test values, from our intervals. So here on the to the left of negative 4 inside this interval, I'm going to choose a test value of negative 5. Between negative 4 and 7 in the middle here, I'm going to choose 0 as a check value between those two numbers. And then to the right of 7, I'm going to choose a test value of 8. So I'll call them test values here. And then in step 4, we draw a table. I'll write each of the intervals I have up above, negative infinity to 4, negative 4, negative 4 to 7, and 7 to infinity. So set up a table with these three intervals. In the first column we put the interval. In the second column we put our check values. Okay, so now we've set this up so it's all nice and organized. Okay, and now we're going to plug into our test values. Are going to plug into the inequality x minus 7 times x plus 4 greater than 0. And to double check, I'm going to put here at the very end greater than 0, greater than 0, greater than 0. And then I'm going to plug the numbers in and see, do we get a greater than 0 from plugging in our test numbers? Starting with negative 5, we'll go negative 5 minus 7 times negative 5 plus 4. That's going to be equal to, let's see, negative 12 times negative 1, which is positive 12. 12 is greater than 0, so this one checks out. If we do 0 minus 7 times 0 plus 4, that's equal to negative 7 times 4, which is negative 28. That's not greater than 0, so that one doesn't check out. Then if we plug in 8, we'll have 8 minus 7 times 8 plus 4. Let's see, that's equal to 1 times 12, or positive 12. That one is greater than 0, and so this one checks out. So now we have our solution. These two intervals are the solution, then the other interval is not part of the solution. So the last thing to do on this question is to go up to the number line where we started, sketch the two intervals that are our solution. So I put a parenthesis at negative 4 and a parenthesis at 7. And then I shade the area where the interval is on the number line for the two intervals that I have checked down below, these two here. Okay, and then we write our solution in interval notation. So let me put just a little bit of space here. Our solution in interval notation is negative infinity, comma negative 4, union the other interval 7 to infinity.